Hey, hello everyone. My name is Roman. I'm a staff software engineer at DFINITY, and today I'm going to make a walkthrough through the ICRC-2 specification, which defines approve and transfer from methods for the ledgers. So this is one of the latest specifications that the Ledger and Tokenization working group was working on. And this is a joint effort of Ossian from Psychedelic and me and some other people from the working group who contributed valuable ideas to the specification. So the working group will have a vote on this specification soon. And the goal of this presentation is to give overview and present the flow, how the specification works, and present some quirks that we found while working on it. We also want to show the difference between ICRC-20 approve and transfer from methods, which inspired the specification, and the ICRC-2, and why we decided to make those changes. So unfortunately, Ossian from Psychedelic wasn't able to join today, so I will do all the presenting, but he contributed most of the work actually. So let's jump in. So first, we will look at the basic flow, how all the methods interact, what are all the parties involved in the flow, and so on. Then we will look at the difference between the ICRC-20 semantics and ICRC-20 semantics, and why we decided to change some things. Then we'll look at small quirks in the specification that we found while working on the reference implementation, and then there will be a Q&A session. Okay, so let's jump in. So first, there are at least 3 parties involved in the flow. We have the owner of the funds, who owns some tokens on the ledger, who implements the specification and keeps track of all the transfers, all the tokens, who owns how much, and so on. And we have the spender, who will be spending tokens on behalf of the owner. So in this model, usually owner is a user or a wallet holding some funds, and spender is a canister which the owner delegates funds to. So you can say, yeah, you can spend some tokens on my behalf, and yeah, usually there is some benefit of doing this. For example, the canister can do automatic trading, or the canister is a shop, so you can allow the shop to withdraw funds from your account in exchange for goods. Yeah, we will look at some other examples later on. So the flow is usually initiated by the owner, who sends a message to the ledger and says that the spender can spend up to specific amount of tokens. So in this case, 200 tokens from a specific sub-account of the owner. And if all the things check out, so in this case, if the owner has enough funds to pay the fee for the approval, it doesn't have to have all the tokens. Actually, it doesn't have to have 200 tokens. Then the ledger tells, yes, transaction succeeded, here is your transaction ID. Just as in the case of the other methods on ICRC-1 standard. So then, after this step is done, the spender can query allowance, and it has to specify the account identified by both the owner and the sub-account. And it needs to pass like the principal, who is a delegate, who will be able to spend the funds. And the ledger will look up the allowance. In this case, the allowance will be 200 tokens. So this is a query call just to check how much I can spend from this account. So once you know how much you can spend, you can actually initiate the transfer to some other party, might be some Bob, I don't know, or can be some exchange, for example. And you specify which account you want to withdraw funds from. You want to specify the account to which the funds will go, and you specify the amount of, like the number of tokens that will be transferred. So for example, if the spender wants to send 50 tokens to Bob, it can do it because it's within the allowance. And then after the transfer is complete, if you query the allowance again for the same account with the same spender, the allowance will drop by 50 tokens, and it will be 150. So far, it's very much like ICRC-20. So why do we even want to have this specification in the first place? Why are we not content with normal transfers? So first, ICRC-2 provides a better, more convenient payment flow for some cases. So for example, if I'm a user and I make a transfer, and then I notify the shop, which is the main payment flow for now. So I make the transfer to the shop, for example, and then I call the shop saying, yes, I made the transfer, ship me the goods. If something happens between those two steps, if you made the transfer and then your browser freezes or your computer shuts off, it might be very hard to get back to the same state you was before the failure. And then you kind of lost the funds, or you need to go through some recovery process to get them back because you don't own them anymore. But if you go for approval first, so you make the approval and then you talk to the shop, and shop does the transfer. If the shop is hosted on chain, then it's very unlikely that it will crash or something happen to the shop. So this flow is much more resilient to networking issues. So then another case which normal transfers do not cover is recurrent payments. So if you want to implement some subscription service like Apple Music or something like that, you want to allow the shop to transfer funds from your account without like having to remember to go and do it yourself, which usually happens with credit cards. So the current interface does not allow you to easily do it. So ICRC-2 enables this flow. And the third case that we thought of is uncertain amounts. So for example, if you have some smart contract which trades on your behalf, it might not know exactly how much funds it needs to spend. For example, if it tries to buy as many tokens as possible for the lowest price, like the exact amount of tokens and like the exact price is unknown yet because it's like moving target. So you can give it some allowance in the beginning of the day, let it do the smart things, take some smart decisions and buy the best price for whatever price was, and spend like some amount within the cap. Yeah, so this was the basic flow. So now let's take a look at the differences between ICRC-20 and ICRC-2. So first, ICRC-2 inherits some of the features which are present in the ICRC-1, which are not present in ICRC-20. For example, sub-accounts, support for memos, support for deduplication of transactions, and some other features, like structured errors, for example. So, but this is pretty much cosmetical difference. There's also a few semantical differences. So first, ICRC-20 has no expiration for approvals. So if you approve something, it's forever until you cancel it by setting it to 0, right? With ICRC-2, we really wanted to have expiration time. So if you approve some amount, you can specify the deadline by which the spender can transfer funds. So for example, if you buy something online, usually the approval should not, like, doesn't need to last for a long time. You can just approve something for 5 minutes, and then if the transfer didn't happen in 5 minutes, then it will never happen. So for example, if you have a payment flow and you approve to the shop, and then you fail to call the shop, as in the current transfer example, right? With the approved flow, your approval will stay forever, and you will need to make an explicit step to remove it, right? So with the expiration times, this won't be a problem. You won't need to do anything. Ledger will just garbage collect all the approvals automatically, which is much more convenient for users. And another difference is that when you approve something on ICRC-20, the last approval wins. So if you approve 100 tokens and then 200 tokens and then 100 tokens again, it will be just 100 tokens. So, and this works fine in a synchronous manner when just you execute one transaction at a time, but internet computer is highly concurrent blockchain. So you might have many transactions flowing at the same time asynchronously. And this design with exclusive approval doesn't work well, as we will see soon in an example. So we decided to implement a different design in ICRC-2 and make approvals additive. So if you approve 100 tokens and then 200 tokens and then 100 tokens again, the total approval will be 400 tokens. They will add up as you approve more and more. So let's look at the interface. What exactly are all the methods in the spec and how they behave. So ICRC-2 approve takes quite a few arguments. So first of them is a sub account. So first of all, it acts on the caller. So if you call approve, the ledger will assume that you want to approve funds for your account because it's like the only type of accounts you can approve for. So you can specify a sub account if you want to allow only one sub account of yours well, you always enable just one account of yours to have allowance. So if you don't specify a sub account, this will be your default sub account. So then you specify the spender, the canister or other user who can spend funds. Then you can specify amount, which is an integer. So it can be positive and negative, which will be the increment. So you increment the approval by this amount. You can specify optional expiration date, which will be the internet computer time in nanoseconds. And you can specify the fee that you expect the ledger to use for this approval, memo and create at a time, which have exactly the same semantics as ICRC-1. We just inherit them because this will be more consistent. So the second API that we experienced or saw before is allowance. So there you specify the account, which is a pair of owner and sub account, and the spender, and the ledger will tell us what's the allowance between those two, like how much a spender can spend from this account, and optional expiration time if it's present. So, and then there is a transfer from endpoint, which is exactly the same as ICRC-1 transfer, except for extra field called from, where you specify from which account you want to transfer. So now you explicitly say, I want to transfer from this account to this account, and the amount you want to transfer. And the ledger will take the allowance you might have for the from account into consideration when it makes the transfer. So let's look at the concurrent calls example, which I mentioned before. So let's say owner and spender are the canisters, and they handle concurrent payments. And spender transfer funds on behalf of the owner. So owner kind of accepts payment requests and spender actually like executes them. So first there is a payment request, owner approves 100 tokens to the spender on the ledger. Now there is allowance between the owner account and the spender of 100. And then it notifies the spender saying, yeah, now you can transfer. And then another concurrent calls comes in with another payment request. Owner makes another approval for, and the request is for 200 tokens. The owner approves 200 tokens to the ledger, but in ICRC-2 semantics, this approval overwrites the previous one. So now the total allowance is 200 tokens, which was the latest number specified. So then spender receives notifications and tries to execute them in sequence. So it executes the first transfer, sends some funds to Alice of 100, and it works fine because the total approval now is 200. The ledger dutifully reduces the allowance by 100 and reports success. But when it comes to the second transaction, the spender tries to spend 200 tokens from the owner's account, but it doesn't work anymore because the allowance is only 100. So only one transaction will succeed from these two. And depending on numbers, usually like the lowest transaction wins. So how ICRC-2 solves this problem? So if you, the difference mostly comes from the additive nature of allowances. So after the second approval, the allowance will be not the 200, but 300. So we'll add up all approvals applicable. So after the first transfer, we will reduce it by 100. So it will be enough funds to complete the second transfer. And then we set the allowance to 0 and everything checks out. So no matter how many approvals and transfers you have in flight, as long as every transfer corresponds to the previous approval, they will all succeed. Yeah, no matter what the ordering between those groups are. So that was the reasoning why we decided to make approvals like additive. So and this API also allows you. So if you want to set it to 0, for example, this poses a little issue, like how do you set it to 0? Because if you approve 0, you will just add 0 to your approval, and it will not change. So that's why we made the amount negative, or allow amounts to be negative. So if you want to revoke your approvals, you can just set it to minus large number, and the ledger will lower it to 0. So if it's 300, you want to remove your approval, you just set it to minus 1 million, and the ledger will just set it to 0 and forget about your approval. So another feature we have is expiration times, and they have a slightly different semantics. So for expiration times, we don't add them, or we don't pick the we don't pick the biggest one, we just pick the latest one. So if you have, just like ICRC-2 would do, right? So we just look at all your approval requests in the order in which they appear on the ledger, and the latest expiration time wins. And if the latest expiration time you don't specify it, saying just I don't care, then we will just reset expiration time, remove it from the consideration, and keep it forever. So allowances add up, expiration time, we just pick the latest request. Okay. So now let's take a look at some quirks that we found, or edge cases that we found while working on the standard. So one question is, who pays the fee for every request? So in our design, every modification of the ledger creates a block on the ledger or transaction in the transaction record. least. So, which means we consume ledger space for each approval, for each transfer. So there needs to be a fee, otherwise there will be attack vector where attacker can exhaust the whole space, for example, easily. So we introduce fees for every operation. I mean, if somebody decides to implement Ledger with a fee of 0, it's also fine. But if it's not 0, then owner pays all the fees. So for approve, we just withdraw the fee from the owner for the approval to keep this record about who can do what. And when the transfer happens, when the spender executes transfer from on the owner's account, it's owner who pays the fee as well. Because the model is basically that we make an illusion that spender is the owner within the allowance, like it kind of acts on your behalf. So the owner will pay all the fees. So another issue that we found is that if the amounts is like an arbitrary integer, right? And in general, amounts in ICRC-1 are arbitrary natural numbers, and they can be very large. So because approvals they do not correspond to real tokens, you don't have to have so many tokens to approve this amount. There is a new attack on the ledger if you approve a very large amount, I don't know, like billions of zeros, like 1 billion zeros, it will consume a lot of ledger space just to keep this huge number. So we decided to explicitly specify in the specification that Ledger can reject your request if your allowance is just too large to keep in a Ledger memory. For example, if the Ledger can never have more than 64-bit number of tokens, then it makes no sense to approve more than that amount. So it can reject your call if you try to approve 2 power 65, for example. Another interesting case is when owner tries to approve to himself or herself. So what should happen? So we decided that if you try to approve to yourself, then clearly you have a bug in your code and we'll just reject your call. Because you already can spend funds on your behalf. There is no point in approving anything. And another interesting case is when you transfer from your account. So in this case, because we work as if you had unlimited approvals for your own accounts, and the transfer from is the same thing as ICRC-1 transfer in this case. Yeah, acts in the same way. Feels very natural to me. And I think that's all I wanted to tell you about ICRC-2. And I would like to answer your questions if you have any. What's the difference between ICRC-1 and the ICRC-2? Yeah, so the difference is that there was different specifications. Maybe I should share my screen again to answer this question. So one feature of the ICRC-1 or ICRC standards that the working group is working on is that they have modular structure. So they kind of build on top of each other. It's not like one huge standard which has all the functions in there. Because we realized we cannot just produce one huge specification in one go, which like works fine. We want to really focus on each aspect in detail, make it right, and then ship it, and then move to the next thing. In my experience, this approach to software works much better. So, and it also works better with legacy systems. So we cannot expect that all ledgers will implement all the standards, but we would like the tooling to be like shared between them. So if you can implement ICRC1 part only, we can build the tooling, and then even if you don't implement the whole set of features, you will still be able to take advantage of those tools. So ICRC1 is the base token standard. It defines very small subset. So basically it has some metadata calls about the ledger. You can query balance and you can make a transfer. That's pretty much it. It's a lot like the old ICP ledger. And ICRC-2 builds on top of this base and adds new methods to it. And you can say, yeah, I implement ICRC1 and ICRC2, and they do not conflict in any way. You can implement just one or just another, for example, no problem with that. And the new specification adds transfer from, allowance, and approve, as we discussed. So the difference is that those are completely different standards, but they complement each other. So do planned SNS tokens implement both of these standards? So the SNS tokens will implement ICRC1 and eventually ICRC2, because SNS will be upgradable, right? So we're working on implementation of ICRC2 as well. I mean, once we vote on it and we know it's final, we will implement it in the DFINITY's implementation of ICRC1 as well. So it will support both specifications, and then you will be able to upgrade your SNS to the new ledger, and you will have approvals. So the above mentioned ledgers, SNS, ICP, and CK-BTC currently support ICRC right now. Yes, so SNS supports ICRC1. ICP is work in progress, so there is ongoing work to add ICRC1 interface to the ICP ledger. Probably will be done by the end of the year, but no guarantees. And CK-BTC will support ICRC1 from day one. Basically, once it's launched, it will be ICRC1 interface. And it will use the same exact ledger that SNS uses. Okay, I guess I answered all the questions I saw in the chat. So hope this clarified the things a bit, and have a great evening, everyone.